the importance of understanding matter in terms of space. Knowing the states of matter helps astronomers understand why space is made the way it is. It helps them find out how celestial bodies formed and understand the composition of the world around us. It answers questions unknown to mankind, such as what happened right at the beginning of the universe?
Solids have a definite shape and volume. The particles in solids have minimal movement, but they still vibrate in place. The arrangement of the particles between each other has a set structure. Liquids have a definite volume but no shape. The particles in liquids are close together but have no specific arrangement, and the particles move and slide by each other, which means that it has a higher kinetic energy than solids, and it always assumes the shape of their container. Gases have no definite volume or shapes. Gas particles spread apart and occupy the entire area of a closed space. The particles move fast and freely, and it has higher kinetic energy than liquids. Plasma is an ionized gas and behaves similar to gas. Plasma has the highest kinetic energy of all the states of matter, and has so much energy that the electrons are stripped from the atoms and buzz around very fast, which means that it conducts electricity.
Formation and composition of stars. To start, stars form in nebulae, which are massive clouds of gas and dust that contain smaller concentrations of gas and dust inside them. These smaller pockets of gas and dust eventually build up enough mass to be crushed by the weight of their own gravity. When this occurs, a protoplanetary disk is formed. Protoplanetary disks are spinning clouds of gas and dust, which get bigger by absorbing more gas and dust. Their core is very dense and hot. This heat kickstarts the process by which stars are born and live, called nuclear fusion. During nuclear fusion, atomic nuclei, starting with hydrogen, are smashed together to form helium, then lithium, and the process continues until fusion of iron begins. Once this happens, the star is no longer able to produce enough energy to continue nuclear fusion, blowing itself up from the core out. The star then becomes a white dwarf, black hole, or supernova, depending on its mass. So where can we find the states of matter in stars? Well, stars are essentially giant balls of plasma, created due to extremely high amounts of pressure created by gravity being exerted on the star. The formed plasma also starts and supports nuclear fusion, and strips electrons from their corresponding nuclei, both of which are necessary for a star to live. Two other forms of matter, solids in the form of dust and gas, can be found in the earlier stages of a star's life, specifically in the nebulae and protoplanetary disks from which they are formed.
Formation and composition of rocky bodies. These form from planetesimals, which are the remains from the protoplanetary disk after a star form, and they come together through gravity and continue to form larger and larger bodies of rock as they collide together. As their mass increases, their gravitational force also increases. These can form things like planets, which are large enough that gravity forces into a spherical shape. They can form asteroids, which are irregularly or spherically shaped. They are made of metals and rocks, and they're much smaller than planets. Planetesimals can also form comets, which are icy and gassy objects that move around the sun. They have a coma, tail, and nucleus, and they form much further out from the center of the solar system, and they have wide and elliptical orbits. Planetesimals can also form moons, which are anything that orbit a planet, and they're usually much larger than asteroids, or they can be asteroids, and they can be irregularly shaped or spherical. Where can we find the states of matter in space? Due to the coldness of space, liquids are not easily found in many of the planetesimals due to a lack of atmosphere on many of them. However, liquids can be found as a solid, such as ice. Gases are also found in many of the objects which form, like comets, and they also make up the atmospheres for planets. They can also be found as ice through deposition on the planetesimals.
The formation and composition of galaxies. Galaxies are a collection of dust, gas, stars, and dark matter that are held together by gravity and formed over billions of years. They contain high-energy black holes at their center that are extremely large and active. Others contain quasars, the most energetic body in the universe, at their center. An image on the right shows a galaxy. Galaxies form when lumps of matter collide to form packs of stars, gas, and dust. These collisions force stars and gases to the outskirts of the newly made galaxy. These galaxies have many spiral arms with many stars in them. Did you know that galaxies are still forming? Larger galaxies engulf smaller ones, an example being of the Milky Way. And galaxies continue to move away from the Earth, which supports the Big Bang theory of the universe. An image on the right shows the formation of galaxies.
The field of astrochemistry. As an astrochemist, you would examine the chemical composition and processes for stars, planets, comets, and interstellar media. To become an astrochemist, you would require a PhD and experience in a field of specialization such as geoscience or chemical biology. You must also have a solid understanding of various concepts like chemistry and astronomical processes. Astrochemists are usually employed by universities, research institutes, or government agencies. Astrochemists explore the interactions of atoms, molecules, and free radicals outside of Earth, and they study the geological processes on other planets. They frequently use Earth-based telescopes, satellites, and space vehicles. They typically collect and analyze data, collaborate with others, and present research to professionals.